Hi, in this lecture I'm going to demonstrate the use of .NET classes StreamReader and StreamWriter, which are used to perform I/O to text files. And so these are classes that are available in the .NET class library namespace system I/O, and when instantiated they provide a standard way to either read from a text file or write to a text file. So StreamReader is a class that allows us to read from existing data in a text file. StreamWriter, when instantiated, is a class that allows us to have our program write to a text file. So the program I've created is called StreamRandWEx1, okay, as in StreamReader and Writer Example 1. And I'm going to take a look at the project's bin debug folder before I show you how the program works and before we analyze the program code. But I want you to see the bin debug folder, which is the folder that is the default location for files that are used by an application. And you've seen this before, so in the card game program that you're working on, the JPEG files that represent the cards are, placed in the bin debug folder, so you're familiar with this already. When we work with text files, this is the location where our text file will be as well. And starting out, you'll notice that there are 4 files, none of which have a .txt file name extension. And that's going to change when I run the program, and I'll explain the details of that here in a moment. But I just want to show you up front that there is nothing, there are just 4 files here in the default file folder, or the debug folder, bin debug folder. Okay, so let me take a look at the program that I've written, and let's look at it from the user standpoint. So starting out, the user is going to see a form that allows them to input data, 2 data items, and then write to a text file one of 2 different ways, either to continue to add records to the next record location when I write in append mode, or to reset the record pointer and write to the first record location, thereby overriding any existing data. So depending upon what I want to do, I may want to just continue to add to the records in a file, in which case I would write in a certain way in append mode, or I may want to completely destroy all the records that are in there and rewrite, in which case I would want to open the file and write in overwrite mode. So let me enter some data. We're going to pretend there's a person in class that gets a 100. And I'll go ahead and write in append mode. Now at this point there is no file, so as I attempt to open a non-existing file and write to it, if the file's not found, then the class is designed to go ahead and instruct the operating system to create a new file. So that'll be the case here. So really, whether I choose append or overwrite doesn't really matter too much this first time, but I'll go ahead and choose append, and a new file will have been created as a consequence of executing that method, and the text that was in the 2 text boxes will have been concatenated and written to the first record location, and then the record pointer, the mechanism that allows me to keep track of the next available record location, the record pointer will be advanced to the next record location. And if I enter another value, so let's say 99, and let's say this person's name is Jen, and click append, then with the record pointer sitting at the second record location, I can anticipate these 2 string values being concatenated and written to the second record location. And I'll add one more, and we'll give this guy 30. And again, the data will be appended and written to the third record location. So my program at this point has been writing to the file, and if I go to the next form, this is a form that reads from the file. Okay, so one form 1, writes to the file, and the other form 2, reads from the file. And if I get the data, it's going to open the file in read access and read it sequentially. And there are the records, and I can see I put the text in the wrong box there, but these are the 3 records that were written to the file. So I'm going to close that, and I return back to form 1, the form that allows me write access to the file. And this time I'm going to enter yet another score, say 99, and let's say this person's name is Tom. And I'm going to then this time write in overwrite mode, and then switch over here to next form and get data, and there's all kinds of records showing up there. That'll become apparent when I look at the program code, but you'll notice that among those records there is not any data that was written previously. So Jen, Chuck, and Sam's records have been overwritten by 4 records that contain data related to Tom. And again, why there's 4 records will become apparent whenever I go through the details of the code. So I'm going to close this writing form again. I also have a button here that I'll show you at the very end that simply creates a new file but doesn't write anything at all, and we'll look at how I'm doing that. So in the event that you just want to create a file but not actually put any data in it, this would be an option that you could choose. So I'm going to go ahead and close up the form and go back to the bin debug folder, and this time we see that there's a file called gamedata.txt, and if I open it with something that reads text like Notepad, you'll see there's the same data that I read with my most recent read from form 2. So there's the data. I'm going to close that up, and now let's take a look at the actual program code. So if I go to form 1, I entered data into text box 1, I entered data into text box 2, right? And then I initially clicked on the on the append, on the button that's labeled append, and I wrote to the file in append mode. So let's see how that's done. First of all, I can't remember whether Visual Studio does this now automatically or not, but you're going to want to make sure that you provide a using statement to be able to access StreamReader and StreamWriter from the system.io namespace. So if that's not there, make sure that you include that or nothing's going to work. And then as we go to this button click event method, this is where all the action is performed. Okay, so what is that? Well, I instantiate the StreamWriter class. I'm writing to the file in form 1. I instantiate the StreamWriter class with a local variable called StreamOut, and I instantiate it by invoking a append text method for the .NET file object. Okay, so this is a little bit different. This is going to perform a task, namely to connect to the file, and it's going to open that connection in append mode so that records are added in sequence, and it's going to require a argument that will be the name of the file that I want to physically store on disk. Okay, and by invoking this method to create the connection, to create the connection in append mode, and to create a brand new file if a file doesn't exist, by invoking this method, it is going to return a object of StreamWriter type. So StreamOut is going to be my object, but it's being instantiated as a result of executing this append text method. Okay, so it's a little bit different than what we've seen before. So syntax is something you need to kind of keep straight and look at closely. All right, so from this point on, I have an object called StreamOut, an object of my own naming choice, and I have available then a method called WriteLine that will take whatever argument it's given. In this case, I concatenate the contents of text box 1 and text box 2. It takes that string argument and writes it to the next available record location, and then advances the record pointer to the new location. And again, it's a method that is available to the object that I've created up here. So I'm going to use the WriteLine object, and I will output to the file, which is currently open. I'm going to clear out the text boxes, and then set focus on text box 1 just as a convenience to the user. And then I've included a statement here that's not absolutely required. It's a call to the StreamReader object's flush method. And so what this does is it finalizes the disk operation and clears out the write buffer, and that's necessary if I want to make sure that all my output goes to disk if I don't close the file immediately. Now in this case, the reason why I've commented that out is because I am in fact closing the file immediately, and if I invoke the close method on a file, it will automatically flush the memory buffer as well. So in the event that I'm not going to close that immediately, then I would want to follow my writes with a flush of the memory buffer. Okay, so every time I click that button, it's going to instantiate a new object. It's going to instantiate it in append mode, and it's going to then write, clear out the text boxes, and close the connection. And by the time the button click event method is done, the program is completely disconnected from the file. So that's the way it works with the file being opened in append mode. Okay, so I use the file's append text method to put it in append mode. The other method that I demonstrated, okay, so if we go to the other buttons click event method, you'll notice that I create an instance of the .NET StreamWriter class in a manner very similar to what I did previously, except this time I do it by invoking the create text method as opposed to the append text method. I'm using the create text method. Otherwise the syntax is the same and the outcome's the same, except when this file's open at this point, having created the object in as a result of executing the create text method, then the object is going to reset the record pointer to the existing file if a file exists, and every time it will then overwrite what was there previously. Okay. Now you may recall when I ran the program there were 4 lines of text. So what I did was, after opening it in overwrite mode, then I executed WriteLine methods 4 times under that current connection. And so with each of those 4 WriteLine, with each time I call the WriteLine method, I give it a slightly different argument, and each time it writes, again, WriteLine will write a new line to the file. So it's going to write these files in sequence. I went ahead and left the flush method in here, so it's going to have a benign effect because eventually I will close the file and that flushes the memory buffer as well. Okay, so That's the program code in both cases. I create my object, use my object, and dispose of my object, all within the event method. So I'm using local variables to instantiate the StreamReader class. There was one other button, and I mentioned that this is a button if I want to just create a file and then use it later. I can do that by instantiating the file either in create text or append text mode. It doesn't matter which one, and then immediately close it. Okay, so without actually executing a write line method, if I just create the object and then close it immediately, it will create an empty file. But the file nevertheless will exist on disk. There just won't be any records in it. Okay, now let's take a look at form 2. This is the form that reads from the file, and so it will read all the records in the file, regardless of whether the file was created in overwrite or append mode. And the code looks like this. I'm still using a class from the system.io namespace, that class being StreamReader. And in my button click event here, I create a class level variable and open the file, and I have to give the name of the file as an argument, so the physical name of the file. Now, if it's in a location other than the bin debug folder, I'd have to provide additional file path information ahead of the file name, but in this case, not having provided any additional file path information, it's understood that it's in the default bin debug folder. So I open the file, and it makes the connection for reading sequentially from the file, and then it also returns this object that I will hereafter have access to, and my object name is StreamIn. Okay, so again, this is just an object of StreamReader type that I'm creating, and I can choose whatever name I want to. I just call it StreamIn. In the next statement, I invoke the StreamReader's readLine method. Okay, notice there are no arguments, so that argument list is empty. Invoke the readLine method, and it will read the record that is currently being pointed to by the record pointer. And so I should have said here too that as a consequence of opening that file, the system sets the record pointer to the first available record in the file, so that when I do my first read line, it's going to return the text from that record that the file pointer is pointing to and store it in this variable inrec. So I read the first record at the time that I create this local string variable. Now at this point, I would anticipate in most cases that it will have read some text, and that this, when it encounters this while statement, the while statement will evaluate true. Once I reach into file, when I read, it will store a special nothing value called null in inrec, and when inrec's equal to null, then the while loop evaluates false, and that's the trigger for getting out of the while. So let's pretend that I do have 4 records in there, let's say. So it would read the first of 4 records and advance the record pointer to the second record position. Then it would check the variable that I read the first record into, find that it is not equal to null, so the while evaluates true, and it's going to put an asterisk in the title bar. Then it's going to add that current value, which is the first record. It's going to add that first record to a list box, and then it's going to do the second and all subsequent reads. Okay, so On the first iteration of the loop, it should read the second record if there are 4. It should find that it's not null. It should add another star to the title bar. It should add the second record to the list box. It should then read the third record, find that NREC is not null, so this is going to be true again. We add a third star to the title bar, add the third record to the list box, read the fourth record. There's text in that fourth record, so this evaluates true one last time. We add the fourth star to the title bar, add the fourth record to the list box, and then read, and this time there are no more records, so it's going to assign null, that special nothing value null, to NREC, and when we come back to the while, this evaluates false. We kick out and close the file, and that's it for the method. Since that's the StreamReader object is a local variable, then once the event method ends, then the object goes out of scope and lifetime. The other thing is I've included all of this in a try-catch. I've put a message box in here, and an option that I have is to use the .NET exception object, okay, an instance of the .NET exception object converted to string, and if it ever takes the catch path, that connection object will store a text description of the nature of the error, and that can be useful if I can understand what the Microsoft message is. It can be useful in trying to determine the nature of the problem that took it to the catch path. So you may want to use this exception object in the future, and this is going to work very much like sender. It's a parameter that will receive the exception object, and then I'm able to take that exception object, convert it to string, and concatenate it into a message. So I give you this code as something to build into your programs in the future. Okay, I think that is pretty much everything I need to tell you. So I'll go ahead and upload this to YouTube and make it available for class.